Hi, everybody. Mary here, and this time we're going to talk about hydrocarbons. Now, hydrocarbons are a group of chemicals that are made of, as you can imagine, carbon and hydrogen. Think of carbon sort of as the Legos of the chemistry world. If you ever played with Legos as a child, you can make gazillions of different things with Legos. You can build castles and dragons and cars out of them. Well, carbons, because of this their ability to build four covalent bonds, can be constructed into long chains. They can be made into rings. They can be made into box-like structures and ball-like structures. They are absolutely amazing. And each one of these compounds is unique. If you mix carbon with its four covalent bonds, because it is a group 4A or 14 element, and hydrogen from group 1, that it has one outer electron and can make one covalent bond, these things can come together and make this huge category of things called hydrocarbons. And this time we're going to talk about specifically the Alkane series. These are just carbons and hydrogens bonded together. And these things commonly make fuels like methane in your gas stove, propane that you might use in a grill, gasoline that powers your cars. And they're pretty easy to name. There's a prefix that tells you the number of carbons and a suffix that tells the bond between the carbons, whether it is a single, double, or triple bond. So let's fill this in, and then we're going to make some of these alkanes. So meth in the alkane series in hydrocarbons, meth means one carbon. Eth means two, prop means three, as in propane, but means four, as in butane, pent means five, as in the pentagon, five-sided structure, sex means six, heps means seven, oct means eight, non means nine, dec means 10, and poly means many, as in polyester, many esters, as in polyester. This might look familiar, hept, oct, non, and dec. This might look a little like September, October, November, and December, a little tiny bit of astronomy and calendar history. Long ago, these were the 7th, 8th, 9th, and 10th months of our calendar, when the calendar had 10 months, and then they chopped the calendar in two, added July and August, and that made September, of course, the 9th, 10th, 11th, and 12th month. But originally, that's where those names came from. The suffixes: ane means a carbon-carbon single bond, ene means carbon-carbon double bond, and ine means carbon-carbon triple bond. So we're going to use all of this information to create some alkanes. So we're going to start with methane. If you have a gas stove and natural gas comes into your home, the natural gas that is piped into your home is methane. Now, meth meaning one carbon and ane meaning single bond. Well, if you only have one carbon, it's going to not have any bonds with any of the other carbons. So it's one carbon, and every carbon will form four covalent bonds. So it's going to have 1, 2, 3, 4, and then it's going to be fully surrounded by hydrogens. So we're going to fully surround that by hydrogen. What I have drawn is the structural formula of methane. That's what it looks like. Carbon surrounded by hydrogen. Now we're going to write its chemical formula. So we're going to take the picture and translate it. When we do this, carbon is always written first. Why? Because this is organic chemistry, and carbon's the big dog. He's the important element here, and then hydrogen comes first. So one carbon, we don't write one, and four hydrogens, and that is the chemical formula of methane, and that is the structural formula. Not too bad? All right, let's do another one. So let's look at ethane. Eth, two carbons. So we're going to have 1, 2 carbons. The ane means a single bond between those carbons, and then we want every carbon to have 4 bonds. So I'm going to surround this. Carbon has 1, 2, 3. There's my fourth. And this one's going to have 1, 2, 3. And there's my fourth. What do I fill it with? It's a hydrocarbon. So I'm going to fill it with hydrogens. There we go, hydrogens on all of those little bonds. What I've drawn is my structural formula. To create my chemical formula, I just count 2 carbons, and then the hydrogens come second, and we count 1, 2, 3, 4, 5, 6, and that is the chemical formula of ethane. What I just drew was a saturated hydrocarbon, and I know you've heard the term saturated fat, and a lot of people don't understand what is a saturated fat saturated with. Well, it is saturated with hydrogen. That means that it is holding all of those carbons are holding all of the hydrogen that it possibly can hold, and that means that there are all single bonds in that carbon. Hydrocarbons that are totally loaded with single bonds tend to be more solid, like butter and lard. Fats that contain more double and triple bonds tend to be more liquid, like canola oil, vegetable oil, the kind of fats you're going to get from nuts, peanuts, avocados, and things like that. And so I just wanted to point that out because a lot of people say, so what is a saturated fat? Well, it's saturated with hydrogen. So let's do ethene. Ethene also has a common name. The common name is acetylene. If you have ever been around welding or have welded yourself, acetylene and oxygen are the 2 common gases used for that purpose. So eth means 2 carbons, and so we're going to have 2 carbons. And ene means a double bond between just the carbons, and then we surround it so each carbon has 4 bonds, and each one of those that is not attached to the carbons is filled with a hydrogen. So I've drawn the structural formula. Now let's create the chemical formula, and we count 2 carbons and 1, 2, 3, 4 hydrogens. That is my chemical formula for ethene, common name acetylene. So let's do ethine. Eth again, 2 carbons. Ine meaning triple bond between them. Oops, that should be a triple bond. I don't think that translated well. 1, 2, 3. And we need 4 around each, so there's 3, so only 1 more is necessary for 4. That's my structural formula, my chemical formula. I'm going to have 2 and only 2 hydrogens. What we've been doing is creating hydrocarbons. And they're pretty simple, and I don't know, I think they're kind of fun. So let's do one that's a little bit more complicated, propane. Now, propane is the sort of thing that you might have in gas cylinders that you use in a gas grill. What happens as you go down this list of hydrocarbons is these methane, ethane have a tendency to be gases at room temperature. But when you get to propane and butane, they are a gas at room temperature, but under pressure, they will be liquids. So propane can be liquefied under pressure, but you open the valve, you're going to get a gas, and it works beautifully for a gas grill. So prop means 3 carbons. So we're going to have 1, 2, 3. The ane means single bonds, and we surround them with 4 bonds to each one, and we fill those with hydrogen. So 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. Fill all those with hydrogen. Draw hydrogens all the way around those. And when we draw those hydrogens all the way around, then we count to come up with our chemical formula. I have 3 carbons, and then my hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, and that is propane. There's my chemical formula for propane. If I can write the number 8, there we go. All right, let's try butane. Butane is 4. Do you want to give this one a try? All right, try butane. I'm going to have you hit pause, write and create butane all by yourself. All right, did you do it? All right, see if you got this one. Bute is 4. 1, 2, 3, 4. Ane is single bonds. 1, 2, 3, 4. Surround this fully with hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my structural formula, chemical formula. 4 carbons and 10 hydrogens is the chemical formula for butane. Now, some of you may be very, very clever and have said, I bet I could construct that in a slightly different way. Well, nature does that too. If you have 2 chemicals with the same chemical formula but different structures, that is called an isomer. And our class is a basic chemistry class. I'm not going to spend a lot of time having you draw isomers, but I want you to have heard the word. And butane is the first of the hydrocarbons that can produce an isomer. And the other isomer of butane is called isobutane, meaning that it is an isomer of butane. And if you construct it in this way and count very carefully, it's going to have exactly the same chemical formula, C4H10. And it is a different chemical with different chemical and physical properties, slightly different melting points, slightly different boiling points, slightly different energy per mole when it is burned. These are definitely different compounds, and I hope you're starting to understand why there can be millions of carbon compounds, because it's the same number of pieces, but you put them together a different way, and you have something new. Think Legos. That is what carbon chemistry is like. All right, see if you can do this one. Don't do anything tricky. Try this. Try and produce octane. Draw for me octane. Simple octane, as in gasoline. All right, let's give this a go. Oct. Oct is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Totally fill this with hydrogens. A lot of drawing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm lazy. I could fill those in. I'm not gonna. 8 carbons and 18 hydrogens. This is my chemical formula. If I filled in all those hydrogens, that would be my structural formula. I hope you also are starting to understand why these molecules are going to have a picture as well as a chemical formula, because you need both. You need to see how it is put together. Now, the bigger the molecule, the more isomers you can have. I'm not going to take the time, you and I are not going to take the time to draw all of the different shapes, the different isomers of these more complex hydrocarbons. But for octane, there can be 18 different ways you can draw them. And I want you to have at least seen these. If you open up a textbook sometime, you will see something like that. And you might go, what the heck is that? That's not that. But chemists are lazy humans like we all are. And that basically every peak is a little carbon hydrogen chain. Each one of this is a carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. And each one of those little peaks is a carbon atom. So that is a shorthand way to do it. If there's a little branch, that is a carbon that is branched off of the main chain. Keep in mind, these things are, as I've said a couple times, the Legos of the chemistry world. That's why there are so many millions of carbon compounds. And when you buy gasoline that has an octane rating at the pump, which of these are you getting? You are getting some of all of them. They are all mixed up together. All right, that will do for this time, and we'll see you later. Bye-bye.